when you have a radical in the denominator, so when you have a square root in the denominator of a fraction, you cannot leave a square root in the denominator of a fraction. It's a huge no-no. So the way that we deal with that, the way that we get rid of it, is by this process called rationalizing the denominator. So the first step of rationalizing the denominator, first concept to help us rationalize the denominator, so we can multiply anything by 1. So multiplying a fraction by 1 does not change its value. So for example, 1/2 times 1 is still 1/2. 1,000,000 times 1 is still 1,000,000. You can multiply anything times 1 and it doesn't change its value. So kind of keep that concept in mind. Why am I having such a hard time? There we go. Second, step 2. Any expression divided by itself is equal to 1. What I mean by that is 4 over 4 is equal to 1. 10 over 10 is equal to 1. Root 2 over root 2 is equal to 1. Anything over itself, anything divided by itself is always equal to 1. So in step 1 we said we can multiply anything by 1 and it's not going to change the value. It doesn't matter. You can multiply by 1 1,000,000 times and it's not going to change anything. And then anything over itself is equal to 1. So what we're going to do is we're going to make what we call a fancy 1. I'm going to take a radical and put it over itself, and that is equal to 1. Root 2 over root 2 is equal to 1. This is just a fancy way to write 1. So this process, to get rid of a radical in the denominator, multiply the numerator and the denominator by the radical that's in the denominator. And then you're just going to simplify. So what you're going to do is you're going to take the square root, you take the radical out of the denominator and multiply the numerator and the denominator by that radical and simplify. So for example, in this first example, 8 over root 2. I cannot leave that square root of 2 in my denominator. That's not allowed. So I'm going to have to rationalize the denominator. I'm going to take root 2 and I'm going to multiply the numerator by root 2. And I'm going to multiply the denominator by root 2. So I have root 2 over root 2. Well, root 2 over root 2, anything over itself, that's just 1. All I'm doing here is I'm multiplying by a fancy 1. I'm multiplying by a fancy 1. So 8 times root 2 is 8 root 2. Root 2 times root 2 is root 4. Well, we know what root 4 is. Root 4 is 2. Square root of 4 is 2. And then I can simplify these whole numbers, these coefficients. 8 divided by 2 is 4. So I'm left with 4 root 2. Okay, let's do another one. I'm going to take the radical out of my denominator, so root 3. I'm going to multiply the numerator by root 3, and I'm going to multiply the denominator by root 3. So this is my fancy 1. I'm multiplying by a fancy 1. Root 3 over root 3, that's just 1. So I make a fancy 1 by taking my radical and putting it in the numerator and the denominator. So I'm multiplying by root 3 in the numerator, and I'm multiplying by root 3 in the denominator. 3 times root 3 is 3 root 3. Root 3 times root 3 is root 9. And what is root 9? Root 9 is 3. And then 3 over 3, those 3's cancel out, leaving me with just root 3. Let's do another one. 15 over 2 root 5. I cannot leave that root 5 in my denominator. So I'm going to make my fancy 1 by taking root 5 on top of itself. Root 5 over root 5. So when you make your fancy 1, only use the radical. Don't worry about the coefficient that's also in the denominator. Only use the radical that's in the denominator. So I'm using the radical to create my fancy 1. So then I'll have 15 root 5 over 2 root 25. Well, 15 root 5 over 2 times root 25 is 5. So I can reduce this. 15 over 5 is 3 over 1. So this will be 3 root 5 over 2 times 1 is 2. Just 2. So this is 3 and 1. And then 3 root 5 over 2, I can't simplify that any further. So we have 3 root 5 over 2. Let's do a couple more. So sometimes I'm going to have a radical in the numerator and the denominator. That's totally fine. The only one that's the problem is the root 3 that's in the denominator. So leaving a radical in my numerator is totally fine. The issue here is that there's a radical in the denominator. So I'm going to do the same process. Take the radical out of the denominator and multiply by root 3 in the numerator and root 3 in the denominator. That's my fancy one, root 3 over root 3. So root 2 times root 3 is root 6. Root 3 times root 3 is root 9. And what is the square root of 9? The square root of 9 is 3. Hooray! I started with the square root in my denominator, and my final answer does not have a square root in my denominator anymore. That's the whole point of this process, is to get rid of the square root that's in the denominator. 3 root 5 over root 15. So I have square roots in the numerator and the denominator. So remember, we can divide radicals with radicals. So if I had 5 over 15, that would divide to 1 over 3. That reduces to 1 over 3. So since I have root 5 over root 15, I can treat that the same way. That's going to be 1 over root 3. So this will be 3 over root 3. So the 3 carried over, and then root 5 over root 15 was 1 over root 3. So the root 3 is in the denominator. So I just cleaned it up a little bit. Now I got to get rid of this root 3 that's in my denominator. So I'm going to multiply by my fancy one. Root 3 over root 3. 3 times root 3 is 3 root 3. Root 3 times root 3 is root 9. The square root of 9 is 3. Those 3's cancel out, and so I'm left with just root 3.